Hello and welcome to this video on practice questions. We'll be taking up examination type questions in this video on momentum, impulse and impact force. So let us start with our question number 1. If you want, you can pause the screen here for a while, try to attempt the question yourself, then play the video again to see if your understanding is correct, or else if you want to continue, you can continue as it is. So let us understand what is happening here in the question. Let us understand what is given in the question. So the figure here shows a hammer being used to drive a nail into a piece of wood. So you're given a piece of wood, you're hammering a nail inside. The mass of the hammer head is given to you. So let us write the data which is given in the question on the diagram. The mass of the hammer head is given to you. What is the mass? It is 0.15 kgs. It is always a good idea to write the details which are given in the question on the diagram. It helps us understand the question better. The speed of the hammer head when it hits the nail is also given to you. The time for which the hammer head is in contact is also given to you. So I am putting some marks on the data which is given to us. The hammer stops after hitting the nail. The hammer stops. So some data is given. From these set of data we can also find the initial velocity and we can find the final velocity. Initial velocity, as I always say, is the velocity which was at an earlier point of time. So at earlier point of time, the nail was, sorry, not the nail, but the hammer was moving. The hammer head was moving at a velocity of 8.0 meters per second. This was your initial velocity, and finally it stopped. Stop means 0 meters per second. So finally, at a later point of time, it stopped. 0 meters per second. So it is very important that we identify the initial and the final velocity to solve the questions on momentum, on impulse, on acceleration correctly. If you do not understand how to identify U, how to identify V, please go through my video on acceleration to understand these points in details. So let us come to the part A. Calculate the change in the momentum of the hammer head. Change in the momentum, change is given by the word delta. P is the short form for momentum. So it is the final momentum minus the initial momentum. V is the final speed, right? Therefore, mv is the final momentum minus initial momentum. U is the initial speed. Let me write it completely. Initial velocity and final velocity. Right? So therefore this is your final momentum minus the initial momentum. Mass is given to you. It is 0.15 times the final velocity minus 0.15 times the initial velocity, which is 8. So the change in momentum will come out to be a negative number, right? So if you multiply these two numbers, here it becomes 0, it becomes 0 minus 1.2, right? So your answer is minus 1.2. The unit can be kg meters per second, or if you want you can give the unit as Newton seconds. Change in the momentum. Momentum has 2 units, right? Alright, so I hope it should make sense. The only question that would arrive is that why there is a negative sign. Sometimes the examiners, even if you do not solve it properly, Even if you give the answer as positive, you get marks. But as you advance in physics, signs are very, very important. So if you can maintain the negative sign and be confident with it, that means that shows your perfection, right? And it is always a good idea to follow the concepts well so that later on you do not make mistakes. State the impulse given to the nail. Impulse is what? What is impulse? The formula for the impulse is Ft. And Ft we know as mv minus mu. mv minus mu we have already calculated in question number, the first part. So you get the same answer here as well, which is minus 1.2 kg meters per second. Alright, let us come to the part C. Calculate the average force between the hammer and the nail. Simple, you are given the time as well in the question. Where is the time? Sorry, this is your time. So what is the average force? Force will be mv minus mu over the time. mv minus mu you have already calculated. Substitute the values over time. Time is 0.0015. So how much is the value of average force? If you calculate it, if you do the calculation, you should get your answer as 800 newtons. Alright, for any doubts anywhere, if you're mistaken, if something is not making sense, please do ask in the comment box, and do not worry with the negative sign, right? Negative sign is correct. Do not worry. Negative sign is the correct answer. Alright, so let us move to the next question, which is your question number 2. So let us understand the question first. Let us read the question and understand what is happening. An engine of an unpowered toy car is rolling at a constant speed on a level track. So the engine is moving. As shown in the figure here, the engine collides with a stationary toy truck and joins with it. So one information that you could take out from here is that it collides with the stationary toy truck. So the velocity of the toy truck, let's call it Vt. Vt means toy truck, stationary truck. So Vt is 0. Before the collision, the toy engine is moving at a velocity. Now the velocity of the engine is also given to you. It is 0.32 meters per second. The mass of the engine is also given to you. Me, let us call it the mass of the engine, 0.50 kgs. Calculate the momentum of the toy engine before the collision. Toy engine, you have to calculate the momentum of the toy engine, which is simple. First question is simple. So the momentum of the engine, let me use the letter P because it is momentum. Momentum is denoted by letter P. Momentum of the engine is mass of the engine times the velocity of the engine. So it is, you have to multiply both the numbers. Simple, 0.5 times 0.32. So when you multiply these numbers, your answer should be 0.16. The unit for momentum is kg meters per second. You need not remember or memorize the unit. You can always derive the unit quickly. The unit for mass is kg, so here is your kg. The unit for velocity is meters per second, so the unit for momentum is kg meters per second. Fine. So we can move on to the part B. The mass of the truck. Now another information has come up. The mass of the truck. Let us write it down in a diagram. It is 0.30 kg. Using the principle of conservation of momentum, calculate the speed of the joined engine and truck immediately after the collision. You have to calculate the speed of the joint. So after collision, what is happening? They are joining. Right? You have to calculate the combined speed of the joined engine and the truck after the collision. Please make note, it is a 3-mark question, right? So that means you have to show your steps working. Why? Because say for example, if your final answer comes out to be wrong, if you are doing all the calculations on your calculator and writing the final answer, right, and if the answer is wrong, if you have not shown any working, you lose all the 3 marks. 3 is a lot of marks. Whereas if your final answer is wrong, if you are showing the steps, then you still have a likelihood of scoring a minimum of 2 out of 3 if your steps are correct. If your steps are correct, you can still score 2 out of 3 even if your calculation go wrong and finally the answer come wrong. So therefore it is always a good idea to show your working. So let us start with the 3-step approach. Step 1 is momentum before collision. Step 2 is momentum after collision, right? How much is the momentum before collision? Let us find out. It is ME times VE. ME is the mass of the engine times the velocity of the engine, MT VT. Total momentum of the engine plus the total momentum of the truck. What is the momentum after the collision? Both the truck and the engine, they stick together. They stick together. So the total mass of the engine and the truck when they stick together is ME plus MT. Say that they move at a velocity of V. What is V? V is the velocity at which the joined engine and the truck move, right? And these two should be equal. Step 1 is momentum before collision. Step 2 is momentum after collision. Step 3 is that you equate them. Fine. So let us input the values in the equation. So ME, VE we have already calculated here. So you can just straight away pick up the values. It comes out to be 0.16 plus VT is 0. So this whole term becomes 0 because VT we know is 0. Initially the truck was at rest. This whole thing equals both the masses combined. So that means 0. Where the mass is? 0.5 plus 0.3. 0.5 plus 0.3. 0.80. Both the masses combined, we are adding ME and MT. We are adding them because they are getting stuck. They are sticking together. 0.8 times V. So what is the value of V? Now it is simple to calculate. If you do the calculation, what answer should you get? 0.2 meters per second. So that's your answer, right? So it is always a good idea to write the steps and then find your answer, because if your final answer, even if you know the steps, if by chance if you do some calculations wrong here or there and the final answer comes out to be something else, if you're not writing the steps, you lose all the marks. You straight away get 0 out of 3. You're losing a lot of marks. But even if your final answer is wrong, say that you gave your final answer as, say that you did some mistake in the calculation and the final answer came out to be 2 meters per second. Say example that you made some mistake. You made some mistake in doing some division by 0, division by 10 or multiplication by 10 error you did and you got a wrong answer. If you have shown the steps, the examiner will see that your step is correct. He'll give you 1 mark here. He'll give you 1 mark here. So you'll score 2 out of 3 on this question, right? Therefore, showing the steps is important. If you do not show the step and the final answer comes out to be wrong, you'd lose all the 3 marks. Showing steps, very, very important if you want to improve your grades. Alright, let us now move on. So these are some extra things. I'll just erase it. That's your working. You can go through it again in your free time. And if you have still any doubts, you can ask me in the comment box. So next question, question number 3. The figure here shows a dummy of mass 70 kgs. Where is the dummy? Dummy is here. The mass for the dummy is 70 kgs. Used in a crash test to investigate the safety of a new car. The car approaches a solid barrier at 20 meters per second and crashes into the barrier and stops. So 2 more data, underline the data and let us identify which is the initial velocity and which is the final velocity. Initial velocity, the velocity which was at an earlier point of time, this was 20 meters per second. Final velocity, it stops, which is 0. 0 meters per second. Easy so far. You have identified all the information. Calculate the momentum of the dummy immediately before. Simple and easy. So momentum will be the mass times the initial velocity. Before the crash, the velocity was 20. So 70 times 20, it is 1400 kg meters per second. Alright, so I hope that this should not create any confusion. This was an easy one. Let's come to the next part. Determine the impulse that must be applied to the dummy to bring it to rest. What is the formula for the impulse? Impulse, which is Ft, is mv minus mu. How much is mv? V is 0. So 70 times 0 minus mu value you have already calculated in the previous step, or you can simply write it again if you want to. So it becomes 0 minus 1400, which becomes minus 1400 newtons seconds, or you can also give the unit as kg meters per second. Both the units are the units for impulse, right? Let us come to the next part. In the crash test, the passenger compartment comes to rest in 0.2 seconds. So this passenger compartment comes to rest in 0.2 seconds. That means the car comes to rest in 0.2 seconds. Calculate the deceleration of the passenger compartment. Deceleration, that means you have to use the formula for acceleration. Simple. Please go through my video on acceleration if you do not understand deceleration and acceleration. The formula for acceleration that we know of is pretty simple, and the only formula v minus u over t. V is, so that's the beauty of writing and identifying all the variables at the beginning of the question itself. Then later on, as you solve the question, things are pretty clear and your speed of solving the question also increases, right? So what is V? It is 0, U is 20. I am noting down the information from here. Alright. And what is the time? 0.2. Alright, so when you do this calculation, what do you find? You find that the answer is how much? You do your calculation, it will come out to be minus 100 meters per second square. Negative means, the negative sign here means it is a deceleration. So what should be your deceleration? What answer would you write here? It is 100 meters per second square. So when the acceleration comes out as a negative number, and if you want to change the name to deceleration, you get rid of the negative sign. Acceleration is minus 100, so deceleration is positive 100 meters per second square. So go to my video on acceleration and deceleration. The video name is Acceleration, to understand this topic in a very completely nicely manner. Let us come to the next part, which is C. The seat belt and airbag bring the dummy to rest so that it does not hit the windscreen. The dummy has an average acceleration of 80 meters per second square. Calculate the average resultant force applied to the dummy of mass 70 kgs. This is easy. You're given the mass, you're given the acceleration. Deceleration is same as acceleration. You simply use the formula for force, F is equal to ma, and this will give you your answer. Mass is 70 times 80, and this will give you your answer, which is 5600 newtons. Fine, easy question. Let us come to the last part. The deceleration of the dummy is less than the deceleration of the passenger compartment. So let us understand what this statement means. The deceleration of the dummy, this person or the dummy who is sitting here, he is decelerating slower. His speed is reducing at a slower rate. So he is getting less amount of a jerk as compared to the deceleration of the passenger compartment, or as compared to the deceleration of the car. Explain why this is the benefit for the safety of the passenger. What is the benefit? What is the benefit? Benefit is that there is lesser impact force. Lesser impact force. Why? Force is equal to ma. If the acceleration is going down, the force is also going down, right? The rate of change of velocity of the dummy is lesser, which is same as acceleration. Rate of change of velocity is acceleration. Acceleration of the dummy is less, so the force experienced by the dummy is also less. It is important. Why? In case of impact, in case of accidents, the dummy will get injured. He's less likely to get injured. In the real life scenario, it will not be the dummy sitting on the passenger car, it will be the real person sitting here. So this is just a crash test. In real life, a real person will be sitting, so the person getting injured, the likelihood of it goes down. This was a video on momentum. Here we also took up questions from impact force and impulse. So practice more and more questions. If you find doubts anywhere, please write in the comment box. I'll get back to you. Thank you.